Here we have another board from my part 2 of the digital tools, or tools for digital circuits learning guide. This one, get this out of focus. There we go. Anyway, this one is the pulse generator. So different push buttons. We use 555s to clean up the push button signal, to debounce it, as it were. There is an inverter down here, so that on this header connector we get a positive going pulse as well as a negative going pulse for each button. Like the others, I have a very nice little Park board to build it up on, which is a lot neater than this. See the kludge of wires behind it. So let's go build this board over at the bench. So, as you can see, we have the circuit board, pretty purple board from Park with the quad push button debouncer circuit on it. This one has, let's see, something to point with. We have the 4 buttons across here. We have a pull-up resistor for each button. So if you remember the 555 from my guide on the 555, the trigger is an active low pulse, or an active low signal. So we have pull-up on the resistors, push the button, it goes to ground, triggers the monostable on the 555. We have 4 555s. Here we have the timing resistor and the timing capacitor. These are capacitors for the control voltage, to basically decouple them to make sure they're nice and clean and stay out of the way. The outputs from these 555s go to the connector, as well as going through an inverter to the other pins on the connector. So we get a positive pulse, negative pulse for each push button. The idea behind this is that the push button will bounce when you push it. It's a mechanical switch, that's what they do. The first time it goes below a 3rd VCC, it will trigger the 555, and the 555 will stay triggered, its output being high, until you let go of the button. So the button staying on, keeping the trigger input low, will hold the 555 in a triggered state, so the output will be high as long as you hold the button. Then when you let go, the timing components, the resistor and capacitor, will take over and hold the output high for that time period defined by those, which the idea there is to give the switch time to settle out, so that by the time the timing is done, the switch is settled back to high and everything's good. So on the outputs, you get a nice clean single pulse for each button press. So let's build it. Get the iron ready, clean it up, clean tin the tip, and we'll start with the resistors as usual, because they're closest to the board. And again, as before, we'll put them all the right way around. There isn't one because they're not polarized, but we'll put them all the same way around. So, and that's kind of arbitrary, doesn't really matter which way. I just like having them all the same way, because it looks nice and neat. As I said before, if you're going to go to the bother of having a board and doing all the work of putting it together, make it look nice. Not only does it show off your skills for a nice looking board, but it's just, another level of attention to detail. Then you have a nice little project that you're happy to have other people look at. So once again, my component bender tool that I 3D printed. Very useful tool. So you get very precisely bent, in this case resistors, same distance out from the body of the resistor, consistent width, fit perfectly into the holes. And one more, and yes, they're all going the same way. No, they're not. No, they're not. Brown, ones. I actually flipped around the third one in. So it's always nice to have a look, make sure, or to do them more incrementally. But since there's only 8, there we go. Now, like before, flip that over, and what I'm doing is spreading the leads so that they'll stay in place when I go to solder. Right. Okay, yeah, that'll be good. Solder iron ready, solder. And let's just put these in here. But it may be a little easier to put one row in at a time since they're so close and they do kind of conflict with each other, but this isn't too bad. There we go. And one more set of pins. There we go. Now clean up those leads. Again, making an effort to keep them from flying off everywhere. These are thin and long, so they tend not to be as much of a problem. If you're clipping something short and fairly thick, then it's really going to go snap when you cut it. And lower weight so it can fly. There we go. Looks good. Looks good. What next? Well, with the idea of starting at the board and working up, I would go with the switches next. We've got these nice little circuit board switches that snap into place. They have the little hooks on their feet, so they stay nicely in place while we solder them. So put the 4 of those on. I think I got 4 of the same height. I got a bunch of them lately, so yeah, that one's a little off. Let's find a better match for that. So we want the thin one. What's this one? Oh, it's a little high. Oh, here's one. No, that's not too low. Yeah, I threw them all in this drawer thinking that it's a little, there's 2 sizes here that are quite close to each other. Actually, I'm finding a bunch of the thinner ones, so I'm just going to grab it. Oh, hold on. There it is. There it is. Okay. Let's do that. That one, I think, is the same height. Yes. Okay. Yeah, it's just a little taller than the thinnest one. That'll be good. Okay, so now they'll stay in place because there's little hooks on their legs. And we can just solder them down. Okay, here we go. Finish those up. There. The switches. Okay. Now, the capacitors, of course, are a bit taller, so I am going to go with the sockets for the 555s. Now, on the two boards that I've recorded already, we've had 20-pin sockets, whereas these are just little 8-pin sockets. Same idea, though. Do these one by one. I'm going to flip it over, and I'm going to bend down two opposite corners, right, which will give us nice, secure socket. And again, keeping an eye on which end is which. There's the notch in the outline on the board, and also a notch in the socket. That matches up with a notch in the chip. Actually, do these have notches? Yes, they do. They have a slight notch in them. Most chips will have a notch in the end. Some will have a circuit, or sorry, a circle by pin 1, which will be at the same end. And some will have a notch all the way through the thickness of the chip. Some will just have it on the surface. There's always going to be some indication. Some might even just have a white dot. But there will always be, there will almost always, probably like in 99% of the time or more, some indication. Oh, we got a problem here. I see that pin was bent down. Sometimes they get munged up in shipping or packaging. Okay, right, the notch. So we go here. Yeah, that's got it. Bend down, opposite pins. Those are all good. Notches all the same way. And then it's just a matter of soldering those. Go. And just keep an eye on things like this where I bent these down, then there's the end of the resistor there. They're nowhere near each other, but same up here. Just it's worth keeping an eye on things like that. Because you don't want any inadvertent shorts. It can make debugging rather difficult. And you don't want to have to debug things. Debugging hardware can be a pain. Even more so than debugging software sometimes. Okay, that looks good. Little splash side, no, that's just some resin. Okay, some flux. Make sure it all looks good. Alright, so now those capacitors. So two capacitors here. One is just a noise decoupling capacitor. It's 100 nanofarads, 0.1 microfarad. Just use a little disc for this. Again, that is connected to the control voltage input, between the control voltage input and ground, which just sort of locks it down so we don't get any false triggering because control voltage fluctuations. And again, we're just going to bend the leads under the board. Under the board? Yeah, under the board, I guess. It's the underside of the board. That's my bottom as opposed to top, so that those all stay in place. And then solder them up. These boards are pretty straightforward. Handful of components, solder them on, done. This one I think is the busiest of the 4 that I did. Circuits themselves are quite simple, but there are 4 of them on the board. Figure that fit well, and that should give you plenty of push button inputs, single pulse inputs to your circuit. Can't really see needing more than that for simple circuits. There we go. Okay, that's fine. So, the other capacitors, these are bigger. These are 1 microfarad. These have a plus and minus, which isn't really marked here. But if we look at the circuit board, let me see, we have, this is the ground pad. If we look at the trace, it comes down, it goes all the way across here. So this is obviously ground. So we locate the ground stripe on the capacitor. That's the negative side. In this case, it's ground. So it goes here. And again, it's the short lead. We'll just put those in here. Make sure they're the right way around. The ceramics don't have a right way around. They're not polarized. The electrolytics, however, are polarized, and too much voltage the wrong way around, they go boom. Or at the very least, you get some smoke. So put them all on the board, bend the leads in the back, make sure the negative side is on the ground connection, all good. So we'll solder those in. Okay, trim the leads. All right. Now, that's the circuit itself done. Now we have this inverter chip. Same thing. Take a socket. 14-pin socket this time. Make sure it's the right way around, because you probably won't be able to see the outline on the board once we solder the socket on. So when we put the chip in, we just have the indicator on the socket to go by. So make sure that's the right way around. And we solder it in. There we go. Now the last piece is the header, and I'm using a 2-row header here because we have 4 circuits, so we have 4 sets of output. We have a plus and a minus, which are noted on the board. So rather than string them out in a single line, I figured double them up so we have pairs of output. That kind of communicates the intent a bit better. So now we tack it on here. 1 pin. Oh, see that moved when I took my finger off. Make sure it's steady, sitting flush on the board. Less of a problem with the dual row because they have a bigger footprint rather than just a single row header, which can tilt back and forth pretty easily. There we go. There we go. Yep. There. So our output connector's on. Now, as before, a couple of wires for power. Same idea here with this version of the board. I thought a bigger connector with the latch and everything would be good, but it's just more awkward. So I decided that just regular size pin headers would be better for that. A little more flexibility, easier to find. So pin 14 is power. That runs all the way up to here. So this one is VCC, or 5 volts. So, as before, melt the solder, put that in like that, and hold it while it cools, because a lot of solder there takes a while. Ground lead the same, melt it, put the wire in, hold it while it cools. I was going to say dries, which is kind of accurate. Okay, once again, some heat shrink. So I'll put this one on, and then I'll put the one across the end, or on the end. So we put that on, we even up the connectors on the end. Yeah, it's pretty good. Okay, here we are. There we go. Nice. Now this, do the same thing. There we go. Power. Now all that's left is put the chips in. We have 5 of them this time. So I'll start with the 04. It's the inverter chip. Make sure all the pins are good. Now you notice the pins splay out, so to put them in the socket, or a breadboard for that matter, you usually have to push. We don't want to do that because that's too much of a push. We usually have to give them a little push to straighten out those pins some. But you have to be gentle, which I just wasn't. So yeah, there we go. And they go in, make sure all the pins are seated nicely and are splayed out or bent. I do the same thing with the 555 chips. There we go. Make sure they're the right way around. Again, sort of practical aspect of aesthetics and keeping things lined up and all the same way with your chips. If you keep your chips all sort of oriented the same way, ones that are in a given direction, then it makes it that much easier to put the chips in. You don't have to worry each one which way it's oriented, which way it's facing, because they'd be all the same. There we go. So all these, they're all parallel here. They're all facing in the same direction. There we go. So let's look at this. This is 4, and so I've numbered them here 1 through 4. The output's 1 through 4. So if we look at this outside pin, it's positive, and it goes negative. Or should I say high, low when I push the button. Now the one opposite it is low, goes high when I push the button. Likewise this, no effect, but it's connected to the second button. So if we do that, and the opposite state, alright, here we go. Oh, get the right button. There we go. Pulse input board. Push button, debouncing, positive and negative, or active low, active high pulses coming out of it. Another useful little tool.